Hello guys and welcome to today's video on finding the equation of a straight line. Yes, this is building on our further maths videos for the Unit 3 and 4 course here in Australia, but this is equally valid for all maths around the world. So hopefully you'll stick with me and watch this video. My name's Darren and otherwise known as MaffsGuru. If you haven't already done so, do me a favour, head over to YouTube and subscribe to my channel. Never going to be rich, and I'm certainly never going to be famous, but I promise you that if you subscribe, it just lets me know that you're watching and gives me that little bit of excitement to continue doing this. MaffsGuru.com is my website. It's got all the videos there, searchable by textbook, and really is pretty awesome if I say so. And you can download all the notes from these videos and what have you as well. So head over there and sign up and tell your mates. That would be greatly appreciated. All right, so by the end of this, we're going to show you how to find the equation of a straight line given 2 points. So previously, we've looked at the idea of y is equal to mx plus c, where we know that if we have a gradient and an intercept, then we can actually write down the equation of a straight line, which is nothing more than a relationship of how to get some x values to some y values. That's lovely, but there is actually another way of doing it, which I think is pretty funky. Because here, with this particular equation, they have to give you the y-intercept. But what if they don't? What if they give you two completely random points on the line, one of which is not the intercept? Well, there's a way to do that. All right, and then we're going to have to be able to find the equation of straight lines, both vertical and horizontal. Again, all of this is building on a previous video. If you've not watched it, head back there and have a look. It's probably some of my finest work. So yeah, we've looked at the idea of gradient is rise over run. We've got this y2 minus 1 over x2 minus x1 is another way of doing it. So here, that's to find the gradient when I'm given two coordinates. So if I'm given two coordinates, then I can find the gradient really easily. This here, I like that, rise over run, because if they tell me the gradient is equal to 2/3, then I know that my rise is 2, my run is 3, which means I'm going to go 2 up, and I'm going to go 3 across to get from one point to the next point. And I can replicate that, 2 up, 3 across, 2 up, 3 across, 2 up, 3, to get as many points on my line as I like. Awesome. And then we have this equation here, which as I just explained a moment ago, is beautiful if they give you the gradient and your y-axis intercept. But sadly, they're not always going to do that. So let's just do a quick example of write down the equation of a straight line. If m equals minus 3 and c equals 10. Well, this is freaking awesome. I've got y equals mx plus c. I know that's my equation of a straight line, or one of them. And so do we know the value of m? Yes, it's minus 3. So where I see an m, I'm going to put minus 3. And I'm going to leave the x there, and the c becomes equal to 10. It's plus 10 because this value here is positive. Now, why do we have these y and x values? Well, generally speaking, it's convention. Again, Barry loves his convention. Here is the x values, and here is the y values. The only reason this is an x is because that is an x. The only reason this is a y is because that is a y. I could perfectly happily have r is equal to ms plus c. Right? That's still there, believe it or not, is the equation of a straight line. The only thing that's different here, and we always keep the m and the c as the same values, is that the r is my y-axis and the s is my x-axis, right? So this r value here is this r value here, and the s value here is the s value here. So again, lots of times we try and trick you in maths by using different letters because you get so used to using x and y's, we throw a spanner in the works and suddenly you crash and burn, and I hate it. Maths is nothing more than a big fat trick, and it offends me that we try and trick you. But hopefully I'm here to teach you about all the different tricks. All right, so what happens when we're only given 2 points? Well, we've said previously we can find the gradient. If we go back to y equals mx plus c, we can find the gradient using 2 points, no problems. We've done this in a previous lesson, so let's do this now. So we have gradient is equal to y2 minus y1 on x2 minus x1. What are my two coordinates? 1 comma minus 2 and 3 comma 2. Right, so y2 minus, minus 2. Now be very careful there, right? This minus sign and that minus sign are not the same, so I have to put minus minus. And x2 is 3 minus 1, right? So minus and a minus becomes a plus. So that's now the same as 2 plus 2 divided by 3 minus 1, which gives me 4 on 2, which gives me a gradient of 2. Now remember, that's 2 on 1. Now that's awesome. So I've got my m, but what am my value of c? Well, that value of c has to be a y-axis intercept, which means one of my coordinates must start with a 0 for it to be a y-axis. And no, they don't. That's annoying. Well, ladies and gentlemen, annoying as it might be, there is a solution. Because there is another equation that we can use that I actually much prefer, because it works all over the place. It doesn't matter if I've got the y-axis intercept or any other coordinate, this equation works. So first things first, let's just go back. We've got our equation, we've got our axes again. Here's my x value and here is my y values. So one of the letters in my equation must be an x and one of them must be a y. So there is my x and there is my y. That gives me my equation. But what the chuffing heck is y1 and x1. Oh, we met that before if you remember. If we go back to our previous slide, we had a y1 and an x1. Where did they come from? They came from absolutely one coordinate. And the great thing about this formula here is that the coordinates that they give you can be any coordinate at all. You just plonk the values into this equation. What else do we see here? The value of m. What does m stand for? Gradient. So actually, this here gives us the ability to find the equation of any line given the gradient and any other coordinate. Now, as I said a moment ago, we're just going to be very careful about the letters in the equation. So when I have y minus y1 equals mx minus x1, this y value and this x value will just always stay. So when they give you a gradient of equal to 4, for example, and let's just say some other coordinate is given by 1, 7, we know that this now is x1 and this is the value of y1. And so I just substitute them in. The y value stays the same. y1 becomes 7 because y1 is 7 is equal to m. We know the value of m is 4. That x stays the same minus the first x1 or that first x value of my coordinate and give me minus 1. And lo and behold. Now actually here is the next problem, because having got this, you can't leave it that way because the equation of a straight line must be written with the y on its own. So we have to transpose this. Now what I could do is add 7 to both sides, which will give me y is equal to 4x minus 1 plus 7. But again, is that in the correct form? No, because we have to have y equals something times x plus or minus some number. So in this situation, we have to multiply out the brackets. So that becomes 4x because we do 4 times x and 4 times minus 1, which is minus 4. We add on the 7, which gives me that y is equal to 4x minus 4 plus 7 gives me plus 3. And there we go. Now we've got my equation in the right form. And what do we notice? Well, m equals 4. Brilliant. That's good. That value in front of the x does give me the value of 4. Tick. Very happy. This plus 3, what is that? That's my y-axis intercept. So we actually know that in this situation here, I also now know that that line crosses through 0, 3. Okay, so here's an example. Let's use it to find the equation of a straight line passing through those 2 points. So they've given me 2 points. I now know that I've got to use y minus y1 equals mx minus x1. Now it's going to seem like a lot of working out, but first thing we need to do is find the gradient. So m, if you remember, is y2 minus y1 on x2 minus x1. So my value of my gradient is, so y2 is 2 minus minus 2 divided by x3 minus 1. So that gives me 4 on 2, which gives me the value of 2. So I now know my m is equal to 2. Which coordinate do I use? Do I use 1 minus 2? Do I use 3, 2? Because they've given me 2 coordinates. There's no direction. I don't know what I'm doing. What the hell? Breathe. Well, actually, as it turns out, you can use either of them. Huh? Oh, yes, we can use either of them. And I'm going to show you that now. So we can now say, let's do this first coordinate first. Y minus minus 2. So this is my y1 is equal to the value of m, which is 2, x minus my x value of 1. So that's now going to give me y plus 2 is equal to 2x minus 1. I'm going to take away 2 from both sides, which gives me 2x minus 1 minus 2. Let's multiply those out. 2x minus 2 gives me y is equal to 2x minus 4. So there, ladies and gentlemen, is using that first equation, or that first coordinate. Let's see what happens if I use the second coordinate. Y minus, so in this situation I'm going to do 2 is equal to m, which we found was 2, x minus, and in this situation 3. Okay, let's see what happens. So add 2 to both sides is going to give me 2x minus 3 plus 2. Let's multiply out my brackets. Gives me 2x minus 6 plus 2, and so y gives me 2x minus 4. Result. Now, which one of those was better? Well, it turns out that using that second coordinate led to one line less, but it doesn't matter which one you use. Find the gradient and use either of those coordinate values. What about using the gradient and intercept form? Well, yes, we could have done this. We could have done y equals mx plus c. Why can I use mx plus c? Well, in this situation, the line, by luck, has actually gone through the value of minus 4. So in this situation, can I work out my gradient? Yeah, let's work out rise over run. So in this situation, m equals rise over run, which gives me how many highs? So it's 2 to minus 2, so that's gone up 4. And how far has it gone across? It's gone from 1 to 3, so it's gone 2 across, which gives me a value of 2. Good, that's what we were expecting. What is my intercept? We know that c in this situation is minus 4, and so we get y equals mx plus c. So m was equal to, it was equal to 2. X and c was equal to minus 4. Now again, we didn't need to do rise over run for this. We could have actually done it the other way again. We could have used that m was equal to y2 minus y1 on x2 minus x1. And again, our second value is 2 minus this value here of minus 2 divided by 3 minus this value here of 1. And again, we get 4 on 2, which equals 2. So either of those ways work. I know which one I tend to prefer. Find the equation of the line that passes through the point 3, 2 and has a gradient of 2. Again, in this situation here, have they given me a y-axis intercept? Nope. And so probably going to be easier to use y minus y1 equals mx minus x1. And again, even if they gave me the y-axis intercept, I'd still probably use this version. So what do we know? We know that we've got 3, 2. That is my x1 and my y1 value. And I've got an m is equal to minus 2. So y minus y1 is 2 is equal to m minus 2, x minus x1, which is 3. I'm going to add 2 to both sides to get rid of that minus 2. So y is equal to minus 2, x minus 3 plus 2. I'm going to multiply out my brackets, multiplying what's outside by what's inside. Minus 2 times x is minus 2x. Minus 2 times minus 3 is plus 6. Ooh, tricky. And so we're going to add that to become minus 2x. And plus 8. And there we go. I love this stuff. What about the equation of the straight line shown in that graph? They have given me 2 coordinate values again. I've also got an intercept. I'm just going to use y minus y1. So what do I have? I have my values of 0, 4, and I have the values of 2, 0. Okay, so let's work out the gradient first. y2 minus y1 over x2 minus x1. So 0 minus 4 on 2 minus 0, which gives me minus 4 on 2, which is a minus 2. All right, so I know I'm going through this relatively quickly. Again, stop, reverse, rewind, see what you need to do. Play it back at half speed, double speed, 3 times speed, who knows? So there's my gradient. Do I have another point? Yes, I do. I actually, in this situation, could use y equals mx plus c, because they've given me an intercept there, so in which case y is equal to the gradient of minus 2x plus c, which is plus 4. That's certainly one way of doing it. Or I can use y minus y1 equals mx minus x1. And again, this is all down to personal preference. So we've got y minus, what value should we use? Well, again, let's use this value of 0, 4. Y minus 4 is equal to m x minus x1, which is 0. Oh, fabulous. Now, when everything x minus 0 is 0, I'm going to add 4 to both sides, which is going to give me minus 2. Now, I'm just going to simplify. X minus 0 is just going to give me x. And I'm going to add 4 on there, and ka-ching, same answer. Again, as I say, personal preference. There are special lines, if you remember, that we need to know. There are vertical lines and there are horizontal lines, and this is all dealt with in a previous video. Now, if we look at the gradients of each of these, if I have a set of axes, and this is x, and this is y, then what do we know? We know that horizontal lines go that way, and they have a gradient of equal to 0, and vertical lines go that way, and they have a gradient of infinity, or undefined, depending on what your calculator says, right? Now, that's a vertical line. It's got a fairly horrendous gradient. How is this important to us? Well, horizontal lines actually have equations. And again, I dealt with this in a previous video. So if I deal with a set of axes again, he says, waiting for PowerPoint to draw this line really, really slowly. And there we go. So here is my x-axis and here is my y-axis. So we know that that's 0, 1, 2, 3, 4, 5, 6, and minus 1, minus 2, minus 3, 1, 2, 3, 4, 5, 6, minus 1, minus 2. Now, if I was going to draw the line y equals 3, what that tells me is that all y values equals 3. So let's think about that. X value is 0, but y value is 3. X value 1, y value is 3. X value 2, y value is 3. So the x values can change. The y values stay exactly the same. So 0, 3, 1, 3, 2, 3, and there we go. So that line there, if I draw it through, is the line with the equation y equals 3. Now, I know that's counterintuitive. It seems weird, doesn't it? Because we say that this is the x-axis, and that's the trick of the question. That's where everyone gets tricked. But if we know that the y values are the same for every single coordinate there, then we know that the equation of the line is simply y equals 3. So where do you think the line y equals minus 2 is? Spot on. Horizontal line through the value of minus 2. So there's y equals minus 2. And what about the value of line y equals 0? Well, again, actually, funnily enough, that's just a trick, because that is the x-axis. So I'm not going to draw a line through there because I've already got a line through there. So y lines, y equals 3, y equals minus 2, y equals 0 are horizontal lines. Vertical lines, same really. If I look at this, x equals 3 tells me that every coordinate has an x value of 3. So 3, 0, 3, 1, 3, 2. Now, there are exam questions that try and trick you this way. They'll give you coordinates and ask you to come up with a line, and it will throw you. But again, if I draw a set of axes and we look at the line x equals 3, then what do? We know that all the x values are 3. So there's one there, and one there. And lo and behold, I have a vertical line through the value of 3. Again, counterintuitive, isn't it? Because we know x is that way, but not for vertical lines. X equals 3 means all of the x values are 3. Where's x equals minus 2? Well, that's going to go through here. So it's going to go through the value of minus 2 as shown, assuming that that there is 0. And x equals 0, as I said earlier in a previous video, that's just a trick. That's another name for the y-axis. Don't get tricked by vertical lines. Don't get tricked by horizontal lines. Well, ladies and gentlemen, there we go. We are done for another lesson. Thank you very much for watching. If you have enjoyed the lesson, let me know. If you're watching on YouTube, leave a comment. If you are watching on MaffsGuru, just, I don't know, subscribe if you could. That'd be greatly appreciated. It's really good to see you. Thank you very much for watching. If you haven't already subscribed, if you can let your mates know, that'd be awesome. Otherwise, I'll see you in another video. Take care. Stay safe. Bye-bye.